Hey there everybody, and welcome to another one of my videos. Today it's going to be something new, and also the sound quality might be a bit ass because I've just moved office, so to say, and I'm actually working in a very empty room, kind of very empty. Anyway, there's going to be a bit of an echo, so I apologize for that. But let's get into it. So today it's going to be Godot, and yes, I am going to name it Godot and not Godot. It's not French, so it doesn't need to have that accent. And yeah, so I'm working on a kind of secret project with Godot, and this is something new for me as well, and that's why I'm learning, and that's why this video is made today. I'm going to show you guys how I've solved making a camera system for a top-down 2D either strategy, turn-based strategy, or whatever adventure game, whatever you'd like. So as you can see, the tile maps over here are set to isometric, and this is just a small tile map that I've made only for testing purposes. And I really had issues with getting the camera to work properly, because you see a bunch of these online videos about setting up the camera and how easy it is to just attach it to a body and then it just follows the body. Well, that's not the case at this point, because, well, we're not interested in following the body or a sprite. At least we're not interested right now. We're just interested in having a camera system that does the following. Let me see. Yeah, let me turn this up. Yeah, here we go. This is the game running right here. It's going to look a bit janky because I didn't set up my OBS very well, but also this is a question. This is following a question that somebody in the Discord for Godot had, is can I set up OBS so that it captures both the editor and the gameplay? Look at that. It does. You just have to set up a different scene that only captures the game, and put a shortcut to either enable or disable it, like so, and then you can switch between them. So here we go. This is the game that I am making right now, and the camera, I wanted to be a 2D camera similar to what you would see in Age of Empires and in many other 2D games, strategy games to be specific. And what I wanted it to do is it should have been able for the player to pan around the map while using the WASD keys, so WASD. And that is exactly what I'm doing right now. Maybe you can hear the clicks on the keyboard for me. So that's one thing that I wanted it to do. The second thing that I wanted to do is to pan when you move the mouse. As you hopefully can see, if you move the mouse to the edges of the screen, it's going to pan. And I wanted to pan properly, as in I wanted to move both on the diagonal if you go to the diagonal. And I also wanted to be pretty snappy. It's not moving very fast, but I want it to be snappy. I want you to quickly be able to change direction. And last but not least, I wanted to have margins, to have limits, so that you don't go scrolling off. That was actually not last. And I wanted it to have margins. As you can see, it has margins. It stops when it reaches a certain amount of pixels outside of the map. And of course, I wanted it to have zoom in and zoom out, which is pretty easy to do. Most of these things are pretty easy to do, but they are not easy to master, as I will quickly explain while I show you the code what I'm talking about. Right, so the camera, oh, I just closed that. I shouldn't have closed it, but it doesn't matter. It should work pretty well with the trick with OBS that I told you about. So let's go into the code, right? So we actually, no, let's not get into the code right now. So we've got our main node, which is the, let's call it the adventure map. We've got the camera 2D, which I've just left it named as a camera 2D. Its position is, I don't know what I did. Yep. Okay. Its position is here at 0, 0 central. So I want the center to be dragged, because you could do it with fixed top left, but it's just not as good, I would say, arguably. And then it has to be the current camera. The zoom is at 1:1, and we will programmatically create the limits once the map loads. And I will show you exactly how I do that as well once I get into the code. Then we've got the tile maps. These don't matter that much. Anyway, yeah. we've got, in my case, it's going to be 3 tile maps, and I'm going to talk more about this game once it's close to a demo, or maybe actually a demo. And then we've got the UI, which at this point is only used to save and to show you the tile as, let me see if I can show you. So I've just started it, Control J. Come on, oh, there we go, OBS picked it up. And as you can see, it shows you where your mouse pointer, on which tile the mouse is pointing once once you're in here. And this can be used later in the game to give you tooltips, right? Tooltips can be above the mouse, but they can also be in a set location on the UI, so that could also help, right? So yeah, so let's get back to it. Okay, so first and foremost, let me show you guys how I calculate the, once I load the maps, how I calculate the limits for the camera. I obviously have a an instance of the camera which can be gotten in ready with the get node camera 2D. That's pretty obvious, I would say. And then what I do is I calculate the half width of the entire map and then multiply it by my amount of pixels per tile width and per tile height. So that's 144 by 72 for me. And then this is the half amount of pixels. And with that half, I set the limits. So I set the limit for the camera on the left, half of that amount of pixels, because remember, the camera is at 0, 0. So if you wanted to point at the center of the screen, you have to go to the half of the map and add that to it, right? And I do that as well. As you can see here, I actually add half of the height pixels so that my camera starts pointing in the center of the map, which maybe you've seen that it did. Anyway, so we multiply for the left limit by -1, and then we subtract another 200 pixels so that it has this, wait, where is it? Yeah, there we go. So that it has this nice limit over here. There we go, 200 pixels. And then for the top, I choose only -120. For the right side, I have another half of the width pixels, and then I add 200 pixels, and then, oh, forgot to move that out of the way. Okay, and then for the bottom, I have the the whole map height, because you have to remember that the coordinates in Godot. I almost made the mistake of calling it Godot. It's because of you internet guys who think you're fancy calling it in with a French accent. But anyway, yeah. So I get the map height and I multiply that by 72. Yeah, because this is just the half height pixels, and then I add another 192 pixels, because it's like 120 plus 72, so that it's exactly the same amount of pixels both top and bottom. Now you might be asking yourself, but what if I'm going to have multiple resolutions? Well, my friend, in that case, I have no idea. I haven't gotten that far. Maybe I'll make a follow-up video in which I address having different resolutions, which is definitely going to be necessary if I'm going to make a serious game. But yeah, anyway, I'll have to figure out how that works, and I'll probably have some way of telling a multiplier, right? Like these values times the desired resolution, and it should look or work as intended. So that's right off the bat, that's preparing the camera, just setting the limits. So once you get the limits that you can only pan to a certain amount, then you have to go in the camera and do a couple of things in here as well, right? Now, why am I actually making this video? Because it seems straightforward, but if you look at my code, it's not that straightforward, right? So what would happen, and I'm not actually going to ruin my code to show you guys, but what would happen in the game if you were to come to the edges of the screen, to the max, to the limit of the camera? If you were to keep, like, for example, I'm on the left side of the map, right? So if I were to keep A pressed, or like the mouse at the edge of the screen right here, my process function, which does my moving, as you can see, experienced Godot developers should understand this. So my process function, which does the altering of the position of the camera, would constantly be iterating through all of this code and keep telling the engine to translate my camera to the left, right? So it would be constantly telling it, okay, go to the left, go to the left, go to the left. But the camera can't go anymore because it's already at the limit. Now, I don't know why the engine itself doesn't have a way of ignoring such requests. In that case, I would have imagined that it does that off the bat, but as it turns out, it doesn't, right? So the problem is that the engine keeps telling the camera, or the engine is being told to move the camera to the left, but it can't because of the limits. So what happens is, if I stop pressing A and I then immediately press D to go to the right, or just move the mouse, it takes a while, sometimes a lot of time, for the camera to actually start moving, and it creates this sticky effect. So instead of being sharp with sharp moves, as you can see right here, it just sticks there to the corner or to the side, and this would happen to all of the sides until all of the calls to move the camera down or to the left or whichever position it was trying to move it, and it couldn't, until those requests sort of die off. I'm not an expert in the engine and in GDScript. I don't know exactly what happens in this process function over here. So I'm by no means an expert, and I can't tell you why did this happen, but I can tell you for certain that it did, and it was very annoying. So if you find yourselves with the same issue, you might want to take a look at my code right here, and I'm going to try to explain this as quickly as I can. You guys can obviously pause the video and look at my code. I'm not going to be posting it anywhere, but you can obviously just copy it off the screen. So what you need to do is actually check whenever you go into this process function, which is like, I don't know, as fast as it can possibly be. I don't even know how fast process gets called. I would assume it's as fast as it can possibly be. So every time you get a action pressed from the keyboard, or you get the mouse position over here, or you get the mouse position at the edges of the screen where you'd like the mouse to start panning, the camera to start panning when the mouse gets in the area. So every time that happens, it tells it makes a move vector with a -1 or whatever you guys have command, so that the global translate or the self.position incrementation can be done with the move vector and the delta, and of course the 300. And I've also set up the zoom effect as well in here, because I wouldn't want the map to scroll much faster than it should when you're scrolled in or scrolled out, or zoomed in or zoomed out. Anyway, and so whenever the mouse is within the position to move the camera, you would also have to check that the position of the camera itself does not go outside of the limit. And if you do that, then there is no move vector. There's like the move vector, actually there is a move vector, but it's 0, 0. So the engine gets a command of move the camera to 0, 0, which it can't do. Nothing happens, so the camera doesn't get stuck. And you have to do this for all 4 positions, as you can see here. For the left side, I've added the self position .x, which is the, remember, it's in the middle of the screen for a right here, right? So this would be the camera. Mind you, when I'm running the game, it's moved further down, and then this is the 0, 0 of the camera, right? So it's the exact center of it, right? So you get the middle position, and then you subtract the half width times the zoom, because if you don't have zoom, then you don't have to multiply it by the zoom. But if you do have zoom, you have to multiply it by the zoom, else this won't work. The mathematics won't work out. And if this is bigger than the limit left, then you can, right, so if the mouse position is correct and this is bigger than the limit on the left, then you can tell the camera to move further left. And then you do the same for right, up, and down. It's just, you can, as I said, you can pause the video, look at the code, and it makes mathematical sense. Right, so this is for the mouse, and then this is for the keyboard. Over here, it's the same, as you can see, self.position.x minus the half width times the zoom must be bigger than the limit left, and then the same thing happens over there. Now, something else. In order for this to work properly, you have to if you have a zoom in and zoom out function, or a zoom in function, whatever, then you probably have the zoom out as well. So when you zoom out, what could happen? So the problem is when you zoom out is that sometimes, let me show you the game. Okay, so when you zoom out, then the camera, the whole map, because there's more real estate on the screen, the whole map would shift to the upwards, right? So if you go like this is the full zoomed in version. Now it's like almost half of screen blank, right? Those 200 pixels, or 120? Yeah, it's 120, I think. So those 120 pixels take up like more than a third of the screen, or maybe a third. When you zoom out completely, that's a lot less, but the camera needs to stay in the same same boundaries, else it would be outside of the boundaries, and then you would press S and you'd have to wait for like a couple of seconds, or maybe move the mouse, and you'd have to wait for like a couple of seconds before the engine gradually increments the camera out of the limit position, and finally it starts moving again, right? So it would get stuck as well when you would zoom out. That's the the basic explanation. Right, let's go back to the code. So when you zoom out, you have to do the same calculations. Mind you, you have to get the viewport again, because the viewport changes, and the viewport tells you what the size for the width half and height half is, right? Wait, do I actually use this? Yeah, there we go. No, wait. I use it, yeah, I use it over here. Oh yeah, correct. I forgot to tell you guys. So for left, it's okay. It's easy to figure out on the left, but on the right, it's you have to calculate the whole viewport minus 30 pixels, and for the bottom, you have to do the same. The whole viewport size on the y-axis minus 30 pixels in order for you to get to the margin of the game, which is over here. This bottom, and then this side as well. In order to get this, you need the viewport size minus, in my case it's 30 pixels, but in your case it can differ, obviously. So getting back to it, you need to, whenever a zoom happens, you need to recalculate the viewport, to re-get the viewport, and then you don't need a viewport in this case. You can just use the old width half and then multiply it by the zoom on the x-axis, and the height half, and multiply it by the zoom on the y-axis, which is, for me, in my case, basically the same. And once you do that, you also have to check, as you can see in these comments, check if your camera has moved out of the camera limits, and just I don't set a translate anymore. I just set it. I set the X in these two ifs, and then I set the Y's in these two other ifs to the proper area, right? And if you do this, then you won't have any issues, and your camera is going to work very smoothly. Again, I don't understand why Godot doesn't actually make these checks on its own, and why the camera gets stuck, but whatever. Maybe this is a feature coming in the future. Hopefully we will see. And yeah, that's pretty much it. That about covers it. I hope you guys enjoyed this. If you are curious about drag, like panning the camera by dragging, as you would on a mobile device, this is not intended for now. There's probably going to be a minimap in my game, which is actually also going to move the camera, and it's also going to have to check if the camera goes out of bounds when you click, because you might be able to click like, if you click like this square, it might want to center that square, but it obviously cannot do that, since, you know, yeah, it just can't do it. It would be centering, it would be outside, well outside of the camera limits. But yeah, anyway, I would like to thank you everybody for watching and listening. Hopefully you guys have enjoyed this video. I've made it a lot longer than it should have been. And I'm sorry that I didn't make it a coding style, like I coded with you guys at the same time experience. I didn't have the time for that. But yeah, anyway, thanks again. Hopefully I'll see you next time, and hopefully yeah, you guys are excited as me for another game, a new game that I'm making. Yeah, thanks. Bye bye.